Here is June 2015, questions 1 to 7. Number 1 says the cost of airing a commercial on television is modeled by the function C of n equals 110n plus 900, where n is the number of times the commercial is aired. Based on this model, which statement is true? So remember, every time you see f of x, or in this case c of n, it's really just a y, so don't let that scare you. And we can tell that this is a linear equation where our slope is 110 and our y-intercept is 900. And now to interpret that equation, if n is the number of times the commercial is aired, and we're talking about how much it costs, then 110, because it's being multiplied by n, that means that it's going to cost $110 for every commercial that we air, which means that we can cross out number 2, and we can cross out number 4. So number 1 says the commercial costs 0 to produce and 110 per airing, up to $900. Or number 3 says the commercial costs $900 to produce and $110 each time it is aired. Well, at 0, if n is equal to 0, and you plug 0 into your formula, let's just try it. Let's see what c of 0 is equal to. 110 times 0 plus 900. Well, we'll get an answer of 900, because 110 times 0 is just 0, and 0 plus 900 is 900. That means that at 0 commercials, we're still paying $900. That's how much it costs to produce a commercial. And we should already know that at 0, our y value is 900 based off of the fact that our b value, our y-intercept, is 900. So again, the choice is number 3. In number 2, the graph below represents a jogger's speed during her 20-minute jog around her neighborhood. So we're looking at a graph, and time in minutes is the x, and speed for miles per hour is the y. Which statement best describes what the jogger was doing during the 9 to 12-minute interval of her jog? So we need to look at 9, which is right here, to 12 minutes, which is right there. So was she standing still? So as time went on, her speed didn't change, okay? But she kept the same speed. So if she was standing still, she wouldn't have a speed, so she can't be standing still during her jog. Was her speed increased? Well, no, because it's the same. She was decreasing her speed? No, it's still the same. Was she jogging at a constant rate? Yes. That constant rate would be 6 miles per hour. That's the rate she was jogging at from 9 to 12 minutes. Number 3. If the area of a rectangle is expressed as x to the 4th minus 9y squared, then the product of the length and the width of the rectangle could be expressed as... What you need to know is the word product. Product means you are multiplying, okay? You're taking two numbers and you're multiplying them. And obviously area, you should know that area equals length times width. So we don't know what the length and width are, all we know is the area. So we know that the final answer is x to the 4th minus 9y squared. So what we need to do is figure out which two binomials could multiply together to give us back what we started with, the x to the 4th minus 9y squared. To do that, we're going to factor. So, if I factor x to the 4th minus 9y squared, I notice that this is the difference of two perfect squares. So if I take the square root of x to the 4th, I'll get x squared. And if I take the square root of 9y squared, I'll end up with 3y. So x to the 4th was first, so that means that the x squared one will be first in our parentheses, and the 9y squared is second, so that means the square root of that 3y will be the next part in our parentheses. And remember, with difference of two perfect squares, you always have one positive and one negative. So that means our answer is choice 2. Number 4, which table represents a function? So if you remember from functions a while back, the rule states that you can have no repeating x values. So if we look at the first one, Do we have any repeating x values? Yes. We have the 2 to the 3 and the 2 to the 7, so that can't work. How about if we look at number 2? Yep, 0, 0 on the x. That can't work. How about 3? So we have 3, 5, 7, 9. So those are all different x values. And even though we have repeating y values, it does not matter. All we care about when we're talking about functions is our x, our domain. The domain values cannot repeat. Number 5, which inequality is represented in the graph below? So if you look here, this is a solid line. Because it's a solid line, it has to be equal to. It's either greater than or equal to or less than or equal to. Since we're shading above the line, it is going to be greater than or equal to, and that looks like this symbol right here. So we can automatically eliminate choice 2 and choice 4 because those are less than symbols. If it looks like a crooked L or a crooked L with a line underneath, you're talking about less than, and the one underneath it is less than or equal to. So this right here is a greater than or equal to symbol. That's what we want. The next part is we need to figure out what is our b value and what is our slope. Well, our b value is where it crosses the y-intercept. That would be at 4. And our slope is going to be a negative, and it's going to be, we're dropping 1, 2, 3 down to the right 1, so our slope is negative 3 over 1, or you could just write it as negative 3. So it has to be choice 1. Y is greater than or equal to negative 3x plus 4. Number 6, Moe's farm stand sold a total of 165 pounds of apples and peaches. She sold apples for $1.75 per pound and peaches for $2.50 per pound. If she made $337.50, how many pounds of peaches did she sell? So first you want to start off with your let statements. So we're looking for pounds of peaches and pounds of apples. That is our unknown. So I'm just going to say that I'm going to have P equal the peaches, and this is pounds of peaches, and I'll just have A equal the pounds of apples. How many pounds of apples we have. So we're only looking for peaches. We only need to solve for P. So we have to come up with our equations first. So if there's a total of 165 pounds of both apples and peaches, then what we're going to do is take the number of peaches that we have, the number of pounds of peaches, P, plus the number of pounds of apples, A, equals our total, which is 165 pounds. The next equation deals with money, and you have to remember cost times quantity equals total. So the cost of peaches is $2.50, so I'm going to have 2.5p plus the cost of an apple per pound is 1.75a times how many pounds of apples equals the total money, which is $337.50. So since I want to solve for P, what I want to do is elimination where my A's cancel, so then I'm just left solving for P. So in order to do that, I need to multiply the first equation by a negative 1.75 so that my A's will cancel. And when I do that, I'm left with negative 1.75p minus 1.75a equals 337, nope, negative 288.75. And underneath, the other equation did not change, so you're still just adding the 2.5p plus 1.75a equals 337.5. So when you do that, your A's will cancel, and when you add up the p's, you'll end up with 0.75p equals 48.75, and then you have to divide by 0.75 to get p alone, and p is equal to 65, which is choice 3. Number 7. Morgan can start wrestling at age 5 in Division 1. He remains in that division until his next odd birthday, when he is required to move up to the next division level. Which graph correctly represents this information? Okay, so Morgan starts wrestling at age 5. If you look at these graphs, you may notice that some have a dot that's filled in. When you have a dot that's filled in, it's equal to something. It equals a value. When you have a dot that is open, it is not equal to, okay? Open dots, they are not equal to, okay? They could be less than a value, they could be greater than a value, they go all the way up to that value, but they're not actually equal to that specific number. So, in this example, we want 5, because that's when he can start wrestling, to be a solid dot, a filled in circle. So we can't choose choice 2 or 4. Okay, so between choices 1 and 3, in choice 1 this is how you read this. So at age 5, you wrestle in Division 1. You wrestle, wrestle, wrestle. As soon as you get to age 7, you jump up to Division 2. Okay? In the third choice, it says you start at age 5. When you're at 7, you can either go to Division 2 or 1. They're both filled in, so they're both equal to. Okay, but this one says, in the actual problem, he remains in that division until his next odd birthday, when he is required to move up. So it has to be choice 1.